Hey there. Have you ever just stopped and wondered how we see anything at all? I mean, it's something we do every single second, but the answer is just so cool. Today, we're going to break down the incredible physics of light, how it bounces, how it bends, and how it, literally creates the entire world we see. Let's get right into it.
So let's start with a really simple question. Go ahead, close your eyes. You see nothing, right? Okay, now open them. But what if you opened your eyes in a room that was pitch black? You'd still see nothing. So it's not just our eyes that are doing the work. What's the missing ingredient here? You got it. It's light. Simple as that. During the day, it's the sun that makes everything visible. At night, we need a lamp or a light bulb to do the job. Without some kind of light source, even with our eyes wide open, we are completely blind. You can think of light as this amazing messenger that brings the entire world right to our eyes. So how does this messenger actually work? Well, it follows a few pretty simple rules. First, light travels in these incredibly fast, straight lines that we call rays. Second, when those rays hit something, a book, a tree, your friend's face, they bounce off and scatter in all directions. And third, our eyes are there to capture any rays that happen to bounce our way. And that is the secret. You're not actually seeing the book. You're seeing the light that has bounced off the book and zipped right into your eyes. Okay, let's talk a little bit more about that bounce. This brings us to our first big idea, reflection. This is exactly what's happening when light hits a really smooth, shiny surface, like, say, a mirror.
So what is reflection? Well, it's really just a fancy word for when a light ray hits a surface and bounces off. Seriously, that's it. Imagine throwing a tennis ball straight at a wall. It bounces right back at you, right? Light behaves in the exact same way. That perfect bounce, that's reflection. And here's the thing, this bouncing isn't random at all. Nope. It follows one simple, totally unbreakable rule. The angle the light comes in at is the exact same angle it goes out at. Think about playing pool. The angle you hit the ball against the bumper is the same angle it bounces off, every time. In physics, we call these the angle of incidence and the angle of reflection, and this rule is true for every single reflection everywhere, no exceptions. Now, flat mirrors are one thing, but this is where it gets really fun. Curved mirrors. And you don't need a fancy science lab to find one. In fact, you've probably got a perfect example sitting in your kitchen drawer right now. A simple, shiny spoon. Go grab a shiny spoon. Look at your reflection in the inside part, where you put your soup. This is what we call a concave mirror, because it's caved in. See how your reflection might look bigger? Now, move it away a bit. Does it flip upside down? Whoa! Okay, now flip the spoon over. The backside, the one that curves outward, that's a convex mirror. What happens now? Your reflection is smaller, right? But you can see way more of the room behind you. This amazing ability to magnify things makes those concave mirrors, the inside of the spoon, incredibly useful. They're what's used in car headlights and flashlights to focus light into a really strong beam. They're used as makeup or shaving mirrors to give you a nice, big view of your face. And yep, that's exactly what your dentist uses to get a super clear, magnified look at your teeth. So why does the concave mirror sometimes make things big and other times flip them upside down? It's all about distance. If something's really far away, the mirror shrinks it into a tiny upside-down dot. As you bring it closer, the image gets bigger, but it stays upside down. But then, when you get really close, closer than this special spot called the focal point, bam, the image suddenly flips right side up and gets huge. That's the magic spot that a makeup mirror uses. And what about the other side of the spoon, the convex mirror? Why is that useful? Well, its main job is probably right on the side of your car. It's perfect for a rear view mirror because it makes things look smaller. It can squeeze a much wider view onto a little surface. This lets a driver see a huge chunk of the road behind them, which is, absolutely crucial for staying safe. The image is always right side up, just a little smaller. Okay, so we've pretty much mastered light bouncing off things. But what happens when light goes through things, like from the air into a glass of water? Well, it does something else amazing. It bends. And this phenomenon is called refraction. I am sure you've seen this before. If you stick a pencil or a straw into a glass of water, it looks like it's bent, or maybe even snapped in two, right where it hits the water. But the pencil isn't actually broken. So what in the world is going on? This crazy illusion is called refraction. It happens anytime light passes from one substance, or what scientists call a medium, into another. And the reason it bends is actually pretty simple. Light changes speed.
It travels at an unbelievable speed through the air, but it has to slow way down to muscle its way through something denser, like water or glass. Let's just break that down real quick. A ray of light is zipping super fast through the air. Then it hits the surface of the water and suddenly slows down, kind of like a car hitting a big patch of mud. This sudden change in speed forces the ray of light to change direction, to bend. And that, in a nutshell, is refraction. So if we know how light is going to bend, that means we can control it. And that is exactly what a lens does. Lenses are just these carefully shaped pieces of glass or plastic designed to bend light in very specific ways. And believe me, we use them all the time. So there are two main types of lenses to know. A convex lens is thicker in the middle and thinner at the edges. It bends light rays inward, bringing them together, or converging them. The classic example is a magnifying glass. Then you have a concave lens, which is the exact opposite. It's thinner in the middle and thicker at the edges. It spreads light rays out. It diverges them. These are often used in glasses to help people who are nearsighted. Have you ever seen a number like this on an eyeglass prescription? This little number tells us about the power of the lens. The D stands for diopter, which is just a unit for measuring how much a lens can bend light. And that plus sign? It tells us it's a converging convex lens. If it were a minus sign, that would mean it's a diverging concave lens. See? Simple. All right, let's do a super quick recap of our new scientific superpowers. We now know that light travels in straight lines. We know that reflection is just light bouncing off stuff, which is how mirrors work. And we know that refraction is light bending when it goes through stuff, which is how lenses work. And there you have it, the basic building blocks of how we see our world. So the next time you look in a spoon, or you see that broken straw in a glass of lemonade, or you watch a car's headlights cut through the dark, you'll know the incredible physics that's going on behind the scenes. So, what secrets of light will you go out and uncover? Go look around and see the world in a whole new way.